this network problem and this technologies has also got some back, what to say, some problems. So I'm sharing my screen. Wait a bit, okay? Can you see the PPT, guys?
Yes, ma'am.
Mm.
Okay, okay, fine. So about surface compaction, we have discussed. Uh, Then drainage method. So I was asking about excavation work. See, if the groundwater level is too high, and in that area, if we do the excavation work, what will happen after doing some excavation? Then the groundwater will rise. It will come up, and as a result, the side walls of the excavated portion will get collapsed. Okay, that is what it is written here. So for this we need to apply some drainage method to remove the groundwater. That is, groundwater is one of the most difficult problems in excavation work. The presence of water increases the pore water pressure and decreases shear strength. This is natural, you know this thing. If pore water pressure is increased, then the shear strength will obviously decrease. Then further inflow of water to the excavation is liable to cause erosion or collapse of the sides of open excavation. That is what I have told just now. Certain methods are available to control the groundwater and ensure a safe and economical construction scheme. So there are various methods available, like electroosmosis is also one of the process. Then there are other processes also. Next is vibration method. So vibration methods can be effectively used for rapid densification of saturated non-cohesive soil. Vibrations and shock waves in loose deposit of such material cause liquefaction followed by densification, accompanying the dissipation of excess pore water pressures. So this method of vibration, it is applied where in case of loose deposits. Okay, and in loose deposits, vibrations are given with some kind of machine. Some setups are there. With the help of those, vibration is applied to the soil, and as a result, the soil gets densified, and the excess pore water pressure that is there, it gets removed because of the vibrations applied. Next is pre-compression and consolidation. So consolidation you all know, and compression also you all know. So this method aims to consolidate the soil before construction. So before construction, this process is done. Since you can see here, pre is added, pre-compression and consolidation. So pre means before. So after the, before the work is completed, construction work is completed, this technique is to be applied, and there are various methods of doing this, like preloading, surcharge fill, vertical drains, dynamic consolidation, electro-osmotic consolidation, etc. So preloading is what? What is preloading? Is the application of load. Okay, some external loads are applied before construction. Then the ground is allowed to compact as required, and then it is removed when required consolidation or compression is achieved. The external load is removed, and then the construction work can be carried out. Then if the time required is less, then only preloading you cannot apply. So along with preloading, vertical drains can be combined. Vertical drains are some kind of these prefabricated drains. Okay, we will study this in details later on. These drains are inserted inside the ground, and then the water is squeezed out of the, or removed out of the ground surface. So if we combine preloading and vertical drains, the process become bit faster. Then dynamic consolidation, already I have told, it is applying the heavy loads, these things. And then next we move to grouting and injection. Grouting, already I have given you an idea, is a process where stabilizers, either in the form of suspension or solution, are injected into the subsurface soil or rock. Some kinds of chemicals or stabilizers, you can say, those are inserted inside the rock with the help of injection process. Okay. And this grouting has got various application. It generally controls the groundwater during construction. So one more process of controlling the groundwater is also grouting. Then it fills the pores, okay, the voids, sorry, it fills the voids to reduce excessive settlement. If there are lots of voids, what will happen? If we apply some load, it will get settled. So what these chemicals which are injected, they fill up the voids, and they reduce the amount of settlement, or it removes the settlement process. Okay. Then strengthening adjacent foundation to protect them against this damage. The foundation, it protects the foundation from getting damaged, because if settlement occurs, first of all foundation will have to suffer. Okay. Then chemical stabilization. So chemical stabilization is already known. It is addition of some chemicals to the ground surface to stabilize the weak soil. So chemical stabilization has been widely used in the form of lime, cement, fly ash, and the combination of the above is also widely used in soil combination, soil stabilization. That is, this lime, cement, fly ash, then other chemicals are also there, sodium silicate and all. So this either these are used individually, or you can combine two or more chemicals and stabilize for stabilizing the work. Okay, the soil. Chemical stabilization reduce permeability of the soil, improve shear strength, increase bearing capacity, decrease settlement, and expedite construction. Ultimately, if you increase the stabilization of the soil, if the stabilization of the soil is done, these things will automatically get reduced, or it will get improved. Okay. Next is soil reinforcement. Soil reinforcement is the form of a weak soil reinforced by high strength, thin horizontal membranes. A large variety of materials such as rubber, aluminium, and thermoplastics have been used successfully. So, I told you here the membranes are in high strength. Remember this word, okay? High strength. These high strength membranes are inserted inside the ground where the soil is weak. Then these are inserted inside the ground to give support or to hold the soil from collapsing. It prevents the soil from collapsing. Then we move to geotextiles and geomembranes. Geotextiles are porous fabrics manufactured from synthetic materials which are primarily petroleum products and others such as polyester, polyethylene, polypropylene, and polyvinyl chloride, nylon, fiberglass, and various mixtures of this. So geotextiles, these are generally manufactured or made from petroleum products. Okay. Geotextiles are used as separators, filters, drains, reinforcement. These are the purposes where geotextiles are used. Okay. Next, other methods. As I told you, there are various other methods, and it is not possible to study each and every one. So, if you are interested, you can search in the net. Then there are few methods also. I have included this thermal method. It is the application of heat or where heat is applied to the soil and for stabilizing the soil. Then moisture barrier method is also there. Moisture barrier method is the process where of minimizing differential movement or differential settlement of a road pavement constructed, the road pavement that is constructed on excessive expansive clay. That is, if a road is constructed on an expansive clay soil, then there will be chances of differential settlement or differential movement. So these barriers are provided so that it is prevented. As also, what happens when we construct the road, the side, there are trees in the nearby areas. Okay. So these trees, the roots of these trees get expanded. So we can insert this moisture barrier to prevent the trees from extending their roots under the pavement. If the roots are expanded under the sealed pavements, there will be various problems like cracks may arise. Some these things may occur. Okay. So this kind of problem, to avoid this kind of problems, this moisture barrier method is used. So like this pre-wetting, pre-wetting is also another process where the soil is made wet. It is allowed to swell by wetting the soil so that it does not create any problem later on. You can get the details in net. Very clear details is there. Then addition or removal of soil, already I have told. The weak soil, if the area is less and if the depth is less, the weak soil can be removed, and in place of that weak soil we can add well compacted materials, well compacted soil. Okay. So is that clear up to this much? If yes, we can move to the next topic. Yes, ma'am. Yes, ma'am. Okay. So before also I have told you that there are various components for applying the various techniques. So now we are going to study about these components little bit. So first here it is components of surface compaction. So generally it is classified under two categories, like light soil compacting equipment and heavy soil compacting equipment. This light soil compacting equipment we can use if the amount of compaction required is less. Okay, and if the amount of compaction required is more, then we use heavy soil compacting equipment. So these are rammers, vibrating plate compactors, vibrotampers, they are classified under light soil compacting equipments. Then various types of rollers like this smooth wheeled rollers, ship foot roller, pneumatic tired roller, grid roller, pad foot roller. These kind of rollers are classified under heavy soil compacting equipment. Now let us see them one by one. So rammers are used for compacting small areas by providing impact load to the soil. This equipment is light and can be hand or machine operated. I think it is clear to you all. Next is vibrating plate compactor. Vibrating plate compactors are used for compaction of coarse soil with 4 to 8% fine. So this kind of compactors we can use if there is 4 to 8, if the soil has 4 to 8% fines. Okay. These equipments are used for small areas. Same, it will be used for small areas because it is classified under light compacting equipments. Then the usual weight of this machine vary from 100 kg to 2 ton. Then vibrotampers is used for compaction of small areas in confined space. This machine is suitable for compaction of all types of soil by vibration. So this machine you can use for any kind of soil, and the work is done with the help of vibration. Here also in vibrating plate also vibration is applied. Okay. Next is heavy soil compacting equipment. We get smooth wheeled rollers, ship foot rollers, pneumatic tired rollers, grid rollers, pad foot or tamping rollers. So these are the various kinds of rollers. So there are, the difference is only in the construction way. Like some rollers has got fitted lugs with it. Some rollers have lugs of smaller size. Some area is small. These things are only different. Rest all same, you know. And most of you, not most of you, all of you have seen rollers in the road. And these smooth wheeled rollers are classified under two categories: static smooth wheeled roller and vibrating smooth wheeled rollers. So in case of vibrating smooth wheel roller, what happens? Vibration is applied. The name is already given. So the most suitable soil for these rollers are well graded sand, gravel, crushed rock, asphalt, etc. So where crushing is required, we apply smooth wheeled rollers. Okay. Then depending on the situation, we will decide whether we should take static smooth wheel roller or vibrating smooth wheel roller. Then sheep foot roller is also a kind of roller. So I'm not going in much details about this. You can just note it down if you want, or you, the notes are available in the portal. You can take the notes from there. If you have any doubt, you can ask. So depending on the type of what kind of compaction, to what, up to what degree you need the compaction level, then what kind of soil is there. So depending on those things, the kinds of types of rollers you can select. Next, we move to components of soil reinforcement. So soil, the characteristic that we'll get after the application of soil reinforcement is development of sufficient friction between earth and reinforcement. Then no interstitial pore water pressure develops within the reinforced earth structure. The placing and compaction of the earth fill layer can be accomplished easily. The soil must conform to certain electrochemical conditions to avoid corrosion. So these are the characteristics that are developed after the application of this process. Then facing element is the component of soil reinforcement. Facing element is the main part or the main structure from where the reinforcements are connected, the remaining reinforcements are connected. The main part or the main structure, you can say, is the facing element. So how it should be, it should retain the backfill between the layers of reinforcement made of either metal units or precast concrete panels, and should be able to deform without distortion. So this is the main important characteristic. It should get deformed, but it should not get distorted. So I hope it is clear what is deformation and what is distortion. Then reinforcement members are composed of thin white strips, also called ties. You know these things, you're familiar with ties. Then should be flexible to ease placement. So there should not be any problem in placing the reinforcement. It should be flexible enough. Should have adequate tensile strength. Should have adequate service life, taking into account corrosion and weathering. So service life should not be too less. Service life should be long enough. Okay. Next, components of grouting. Grouting is injection of pumpable material to increase its rigidity. The jet grouting is quite advanced in speed as well as techniques when compared to general grouting. So jet grouting is the most used method of grouting nowadays. Okay, it is the new technology and it is used in most of the works, most of the grouting process. This jet grouting is used nowadays. The equipment consists of a jet grouting string of almost 7 to 10 centimeter diameter. At the end of this string, it possesses a nozzle in order to have an injection at a higher velocity. The nozzle is small, of diameter ranging from 1 millimeter to 10 millimeter. It's clear, I guess. Then components of chemicals, stabilization of soil. So calcium chloride, sodium silicate, these are the various chemicals. Also lime, fly ash, cement, these things are also included in chemical stabilization. There are various chemicals. We cannot name all. Okay. So here some of it has got few characteristic, like calcium chloride being hygroscopic and deliquescent, is used as water retentive additive in mechanically stabilized soil bases and surfacing. Hygroscopic and deliquescent. So these are the characteristic of calcium chloride, means it can absorb the water. It can absorb the water very soon. And so it is used as water retentive additive, means it retains the water. It does not allow the water to flow. It absorbs it absorbs the water into it, and so uh, we can use it in mechanically stabilized soil bases. Similarly, sodium chloride is also another chemical that can be used for this purpose, with a stabilizing action similar to that of calcium chloride. So sodium chloride has got almost similar properties like calcium chloride. Sodium silicate is also another chemical used for this purpose in combination with other two chemicals. So sodium silicate you can also use in combination of this calcium chloride and sodium silicate you can mix, or sodium chloride and sodium silicate you can mix. This chemical is used with the mixture of these two chemicals. Okay. So these are the various components of ground improvement techniques. I hope it is clear till this much. Is it clear? Okay. So, any doubt till this much, anyone? Any doubt? You can ask. Any doubt? At least respond. Yes, no. You can write in the chat box also. No, no, no. All no. Okay, no doubt. Okay, fine then. If you guys are having no doubt. Okay, then let us end this class here. We will meet in the next class again. Fine.